Hello students, in this video we are going to discuss 5.5 and 5.6 from Magnetism and Matter. A bar magnet of magnetic moment 1.5 Joule per Tesla lies aligned with the direction of the uniform magnetic field 0.22 Tesla. Aligned with the direction of uniform magnetic field. That means the angle between magnetic moment and magnetic field is 0 here. What is the amount of work required by an external torque to turn the magnet so as to align its magnetic moment normal to the field direction and opposite to the field direction? What is the torque on the magnet in cases 1 and 2? Here, the given data is magnetic moment M is equal to 1.5 Joule per Tesla and magnetic field B is equal to 0.22 Tesla and initial angle I am writing theta suffix I is equal to 0. Now we'll discuss sub-question A. What is the amount of work required by an external torque to turn the magnet so as to align its magnetic moment normal to the field direction? That means theta final is equal to 90 degrees. In this case, the work done. So work done is equal to actual formula minus MB cos of theta final minus cos of theta initial. That is equal to minus of 1.5 into 0.22 cos of 90 minus cos of 0. That is equal to minus 0.33 into 0 minus 1. Its value is plus 0.33 Joule. And it is 1. In that second subpart, in the A itself, second subpart, opposite to the field direction, that means theta final will be 180 degrees. So in this case, the work done will be minus MB cos of theta final minus cos of theta initial. That is equal to minus 1.5 into 0.22 cos of 180 degrees minus of cos 0 degrees. That is equal to minus 0.33 into minus 1, that is equal to plus 0.66 Joule. So this is the work done in both cases. While coming to B, in the first subpart, we need to find out the torque. Torque tau is equal to, we have MB sin theta. Initially, it is normal to the field direction. That means theta value is 90 degrees. That is equal to 1.5 into B is 0.22 into sine of 90 degrees. Its value is 1.5 into 0.22 into 1 is equal to 0.33 Newton meter. Second case, torque tau is equal to MB sin theta, but Here theta is opposite to the field direction. That means 180 degrees, 1.5 into 0.22 sine of 180 degrees. This is equal to 1.5 into 0.22 sine of 180 is 0, overall 0. So this is work done in both cases and torque in both cases. Coming to 5.6. A closely wound solenoid of 2000 turns and area of the cross section 1.6 into 10 power minus 4 meter square carrying current of 4 ampere is suspended through its center along it to turn in horizontal plane. What is the magnetic moment associated with the solenoid? What is the force and torque on the solenoid if uniform horizontal magnetic field of 7.5 into 10 power minus 2 Tesla and angle 30 degrees. Here the given values are number of turns are 2000 and area of cross section 1.6 into 10 power minus 4 meter square and the current value is 4 ampere. Now we need to find out the magnetic moment associated with the solenoid. So magnetic moment M is equal to NIA, that is 2000 into 4 into 1.6 into 10 power minus 4. After simplification, we'll get 1.28 ampere meter square. So this magnetic moment acts along the axis of the solenoid in a direction related to the sense of current via right hand screw rule. The direction will be direction of M is along the axis and it is decided by the direction of the current. While coming to B, what is the force and torque on the solenoid if uniform horizontal magnetic field of 7.5 into 10 power minus 2 Tesla is set up at an angle of 30 degrees with the axis of the solenoid? Here we can write B is equal to 7.5 into 10 power minus 2 Tesla and theta is equal to 30 degrees. In this case, net force F net is equal to 0. When magnetic dipole is placed in uniform magnetic field, the net force acting on this one will be 0. Suppose this is uniform magnetic field and magnetic dipole is placed like this. So the magnetic moment will be like this. It experiences a force MB force like this and force like this. Here both forces will be equal in magnitude but opposite in direction. Then its value will be 0. That is its value is nothing but magnetic charge into magnetic field here. This is also nothing but magnetic charge into magnetic field. While coming to the torque torque tau is equal to mb sin theta, that is equal to 1.28, previous we got it, and b value is 7.5 into 10 power minus 2 sine of 30 degrees, that is equal to 0.048 Newton meter. Will get it. This torque tends to align the axis of solenoid along the field.